Hello boys and girls, welcome to Mrs. Bandu's Math Movies. This is for Algebra, Lesson 2-3, Multiplying and Dividing Rational Numbers. Here we will not only look at multiplying and dividing these numbers, but look at several properties and concepts that we use when we're doing this. So here we go, we've got a lot to fill in today. So the identity property of multiplication tells us that for every real number n times 1 equals n, and 1 times n equals n. Didn't leave us a lot of room there, but anyway, okay? So 1 times 5 is 5. 1 times -5 is -5. The multiplication property of 0 tells us that for every real number n times 0 is 0, or 0 times n is 0. So 35 times 0 is 0, and -35 times 0 is also 0. Again, these are things that you know and use every day. We do have names that we need to put with them and identify them as well. The multiplication property of -1 tells us that for every real number n, -1 times n is equal to -n, or the opposite of n, or n times -1 is equal to -n, or the opposite of n. -1 times 5 is -5, and -1 times -5 is 5. Multiplying numbers with the same sign. The product of two positive numbers or two negative numbers is positive. 5 times 2 is 10. Similarly, -5 times -2 is also 10. The product of a positive number and a negative number, or a negative number and a positive number, is negative. 3 times -6 is -18, or -3 times 6 is also -18. Both of those giving negative results. Let me move down a bit. Okay, dividing numbers with the same sign. The quotient of two positive numbers or two negative numbers is positive. So 6 divided by 3 is 2. -6 divided by -3 is also 2. Dividing numbers with different signs. The quotient of a positive number and a negative number, or a negative number and a positive number, is negative. -6 divided by 3 is -3. And 6 divided by -3 is also -3. And we have the inverse property of multiplication. For every non-zero real number a, there is a multiplicative inverse 1 over a, such that a times 1 over a is equal to 1. So, for example, 5 times 1/5 is equal to 1. -5 times -1/5 is also equal to 1. The multiplicative inverse of a non-zero rational number a over b is b over a. Okay, basically you invert it or flip it. A reciprocal is a numbers multiplicative inverse. So if we peek back up here, 5 and 1/5 are reciprocals because they are multiplicative inverses. Those terms can be used interchangeably, but you should recognize each term. All right, going on to our examples. A lot of definitions there. Multiplying numbers. We want to simplify the expression -6 times 3/4. So the product of a positive number and a negative number is going to give us a negative result, or in this case, a negative product. Okay, and remember, if you have, oh my goodness, you can't see. There we go. That might be a little better. The product of a positive number and a negative number is negative. All right, so we have -6 times 3/4. Remember, some people actually still like to write the 1 under the 6. The shortcut to turn a whole number into a fraction is to, or an integer into a fraction, is to plop a 1 down underneath it. So I multiply numerators and I multiply denominators, or -6 times 3, which is -18. Here's your negative sign right here. I often actually, in writing it myself, I put it up here rather than out to the front so that I don't kind of lose it in all the symbols and such. It's your call as to how you want to do that. Just please be sure that it's easily recognizable. And of course, 1 times 4 is 4, or you would just keep your same denominator, however you care to look at that. Okay, so we're going to write -18/4 as a mixed number. And remember, that takes 18 and you divide by 4, so that's 4 with 2 left over, which is -4 2/4, which is -4 1/2. Okay, most of you will probably be able to do many of these types when the numbers are not too large. You're probably going to be able to do that in your head, and that is certainly reasonable. Okay, use the function t is equal to -5.5 times the quantity A divided by 100 degrees Fahrenheit to calculate the change in temperature for an increase in altitude A of 7,200 feet. Okay, so basically what we're doing here is we're going to be substituting in some information. Okay, so here is that little function, and in that function we're going to substitute 7,200 for the A. Okay, 7,200 divided by 1,000 is 72. And 5.5 times 72 is, oh, excuse me, that is actually -5.5 times 72 is -396 degrees Fahrenheit. Okay. Multiplication on that one isn't too bad. I'm going to double check here so that I did in fact get it right. 5.5 times. Okay, yeah. Should probably be able to get by without doing it in a calculator. I just wanted to double check it here. Okay, now number 3. This is actually a very important example because you want to pay careful attention. They look almost the same. Letter A is the opposite of 2/10 to the 4th power. Letter B is -2/10 raised to the 4th power. Means something a little bit different. Because this negative sign is not encased in the parentheses, it actually basically stays with your answer. Okay, so so 2/10 is the repeated factor. All right. So this is really the opposite of 2/10 raised to the 4th power. So 2/10 to the 4th power is 0.0016. And my negative sign stays there because I want the opposite of 2.2 raised to the 4th power. So -0.0016 is your answer there. All right, this one is a little bit different, and I like to, because the parentheses is includes the negative sign with the 2/10, that negative sign is sort of stuck with that 2 wherever it goes, or that 2/10. So this is -2/10 times -2/10 times -2/10 times -2/10. Okay, 1, 2, 3, 4. 4 negative factors is going to give us a positive result. The multiplication still gives us the same numerical piece of our answer, 0.0016. Again, though, because I had an even number of negative factors, my answer is the product is in fact positive. Okay, and we will look at a few more similar to this in class. I'm sure you may have some questions, so if you do, please jot them down or just make a mental note to bring them into class. Please finish the quick checks for this section. You have one here and a second one on the next page. I look forward to seeing you in class again. Thank you.